Jai Shri Gurudev. This is Ravi Kumar Tier, Assistant Professor from Mechanical Department. Today we're going to learn about in the DME-II subject, the Module 1 curved beams. Today what we're going to discuss first, what do you mean by beams? Next, straight beam, curved beam, difference between straight beam and curved beam, then stresses in curved beam. So what are beams? Beams are slender member. Beams are slender members. It carries only a transverse load and external movement. It's already know about in the third semester of mechanics of material, right? Now the beams are classified here based on the axis of the beam. What do you mean by axis here? There are two types of axis here. One is centroidal axis, another one is neutral axis. Centroidal axis means the axis it is related to the geometry. The center of the geometry, if you join all the center of the geometry, then you will get that axis is called as a centroidal axis. If you join the center of the geometry of all the planes of the beam, then you will get a centroidal axis. It is a geometric centric we call as. Second one is neutral axis. Neutral axis means on the axis in the beam in which the stresses are zero. That's called as a neutral axis. Now based on the axis of the beam, the beams are classified into one is straight beam, another one is curved beam, right? Yes, first we discuss about straight beams, or simply called as a beams. What is a beam? The axis of the beam is straight or linear. What mean by axis means? It may be a centroidal axis, another one is neutral axis. The axis of the beam is straight or linear, then that type of beam is called as a straight beam. This is how the construction of straight beam. When the straight beam is subjected to an external movement, on left side is clockwise, right side counterclockwise. Now how the beam is deflected like this. Here the centroidal axis and neutral axis in the straight beams are coincide, right? The neutral axis stresses are zero, right? Now above the neutral axis the fiber undergoes compression, below the neutral axis the fiber undergoes tension. Then if you pass a arbitrary cutting plane, now this is the assume this is a rectangular cross section. How the stresses are distributed here? Okay, from the center neutral axis draw X line and Y line. Now above the neutral axis the fiber undergoes what? Compression, that is in negative in nature, the tensile stresses, and below the neutral axis tension, again tensile in nature. This is previous it is compressive in nature, is the tensile stresses, and below the neutral axis is a tensile in nature, again this is positive x direction. This is how stress is distributed. Stress is distributed is linear, already we know in the mechanics of material, and right. Now some of the example for straight beams are the beams of a building, railway tracks, vehicle chassis, gear levers, etc. This is some example. Now how do you determine the stresses induced in the straight beam? By applying a pure bending moment equation. Means throughout the length of the beam the bending moment is constant. That's called pure bending moment equation. That is mb by I is equal to sigma b by y is equal to E by R. From this you use only these two terms. If you use only these two terms, sigma b is equal to mb by I into y, where mb is nothing but external bending moment, I is area moment of inertia, is a cross-sectional property, and y is distance from neutral axis to the outer fiber, right? Next we'll go discuss about curved beams. Then what are curved beams? The axis of the beam, it may be a central axis or neutral axis, or not a straight, it's a curved in nature. But in curved beam both the central and axis are not coincide, right? Always the neutral axis comes towards the center of curvature. towards the center of curvature, and the neutral axis lies between central axis and the center of curvature. This is called as center of curvature or center of that beam, right? Now when the beam, the curved beam is, this is the construction of curved beam, when it is subject to an external bending moment, an external bending moment, what happens? Above the neutral axis, the fiber undergoes compression. Below the neutral axis, the fiber undergoes tensile. Now if you go for, see the, assume this is a rectangular cross section by passing an arbitrary cutting plane here. See the rectangular cross section. Now this is central axis and neutral axis. At neutral axis, stresses are 0. Above the neutral axis, the fiber undergoes what? Compression, that is in compressive nature, negative x-axis. Below the neutral axis, the fiber undergoes tension when it is subject to an external bending moment, that is in a tensile in nature, that is positive x direction. This is how the stresses are distributed here. The stresses are distributed is not linear, it is also a curve. Stress distribution is non-linear or curve. So some of the examples for curved beams are, consider the building arches, C clamps, crane hooks, which is used to uh, lift the loads in what is the crane hooks, you can see in the cranes. Then frames of presses, riveters, punches, shears, boring machines, planers. Other examples for is, consider the ring, earrings or bangles. There is also curved in nature. And chains, they such as dog chains or anchor chain. These are examples of curved beams. And next, what is the equation of stresses induced in the curved beam? How do you express that equation? Later we'll derive this equation. For here, just see, note that bending stresses in curved beams is mb by ae into y divided by rn plus y. What is mb? mb is nothing but external bending moment. External bending moment. A is the cross section of that area of the cross section. E is the distance between the central axis and the neutral axis, eccentricity we call it, this is the eccentricity. And y is the distance from neutral axis to the outer fiber, it is in positive y direction or in negative y direction also. And rn is nothing but the radius of the neutral axis, a neutral axis radius from the center of curve, center of the geometry, sorry, center of the curvature to the neutral axis. That radius is called the radius of the neutral axis. Later we'll discuss. And then this is what we discuss, what do you mean beams, straight beams and curved beams. When you go for difference between straight beam and curved beam, based on parameter you go for discuss. One is definition, that is the axis. In straight beam, the axis of the beam is straight. In curved beam, the axis of the beam is not straight or curved in nature. Second one, go for construction, and then how the stresses are distributed. Third one, examples for straight beam and curved beams. And fourth one is what is the stresses induced in straight beam and curved beam. These are four parameters you remember, that gives a difference between, that is right in the table, that gives a difference between curved beam and straight beam and curved beams.